Question number 18, and it's testing our quality of written communication because there's an asterisk next to the 18. The sum of the squares of two consecutive integers is 1 greater than twice the product of the integers. For example, 9 squared plus 10 squared is equal to 81 plus 100, which is 181. And twice the product of the integers, or 9 times 10 is a product of them, twice is 2 times that. 2 times 9 is 18, 18 times 10 is 180. So it's always 1 greater. Okay, now prove this result algebraically. So first off we're going to set let the first integer equals n. So the next, the consecutive integer is the next one, n plus 1. So we're now going to do the sum of the squares. So the sum of the squares, is n squared plus n plus 1 squared. So I'm going to expand that out now. I've got n squared plus n plus 1 times by n plus 1. So n squared plus n times n is n squared. N times 1 is plus n. 1 times n is n, and 1 times 1 is 1. So we've got n squared plus n squared, 2n squared plus n is 2n plus 1. So I can factorise these first two terms here. I can take out the number 2 and the letter n. So 2n times by, inside the bracket there, 2n times by n is going to be 2n squared, and 2n times by n plus 1. Plus my 1 that I've got left here. So I can now see that this is twice the product of the integers, because here is my, so I've actually got there 2 times the first integer, which is n, times by the consecutive integer, and then I've got plus 1. So I proved algebraically that the sum of the squares of two consecutive integers is 1 greater than twice the product of their integers. So twice the product of their integers plus 1.